Hey guys, here's proof number 3 from the test. We're given this picture here. We have this triangle with side JL congruent to LK, right? That's given to us here. That means that this is an isosceles triangle. So the way proof works, guys, is like this. We're given an isosceles triangle. So here's a picture of one, right? Just some generic isosceles triangle. Doesn't matter. We're just saying that if you have a triangle and two sides are congruent. And also we know this fact that if you draw, like this segment in the isosceles triangle and it cuts this angle, that's bisects angle JLK, so JLK, so we're cutting this angle right here in half. That's what it means to bisect it, right? That segment LM cuts that in half. Then we can prove that M is the midpoint of the base. So if you have an isosceles triangle and you just bisect this angle here, in fact, let's actually just do that, right? So I'm going to put a segment here on top of our triangle, and then I'm going to make sure that we have an isosceles triangle. So I'm going to use my compass tool. I'm going to make this vertex point here the center of my circle, and I'm just going to go out to this point J, and notice it collects that point over here. So now when I use my segment tool again and draw another radius, then those are guaranteed to be equal in length, right? Those sides there, those radii, are equal in length. So therefore, we're guaranteed that those two sides are congruent. So now let's go ahead and just connect our base. There's our isosceles triangle, right? So no matter what, oops, not proof, problem. So no matter what, this is an isosceles triangle, right? That's what our circle proof allows us to say. Okay, let's put our problem back up here, and I'm going to move my isosceles triangle to look just like our picture there. So we're given the fact, well, I'm using this JL is congruent to KL, right? So that's what allowed me to make that isosceles triangle. That's what that really means, okay? So now let's use the fact that this LM bisects angle JLK. So that's this upper angle right here, vertex at L, right? So I'm going to grab my angle bisect tool, actually. And I'm just going to click on this angle, which would be JLK, right? And notice we get this line to go right down the middle of that angle there. So what that means is where that angle bisector meets our base at point M, then this means that M is going to be the midpoint, right? It means that now, if I measure, for example, the distance between this endpoint and that intersection point, and then the intersection point and the other endpoint, remember that those are going to be the exact same number. And notice that they are, right? So M truly is the midpoint of JK. So if you have an isosceles triangle and you bisect the vertex angle, meaning cut it in half, then we get the intersection of that angle bisector to be the midpoint of the base, right? It's just symmetry. It's the fact that if you cut this triangle in half, then you're going to get two equal triangles, and that's what we're proving, right? So, and actually the logic has to flow with the fact that if you have an isosceles triangle, we can prove that these two triangles are congruent. We have to do that with, remember, a side-side side or some kind of combination that proves that the two triangles are truly congruent, meaning all 6 parts are truly congruent by only looking at 3 parts. Okay, so let's look at the proof of this one here. So proof, first of all, we take what we were given. We're given the fact that this angle up here gets bisected by that segment LM, right? Got cut in half. We're given that fact that we used. We're also given the fact that we have JL is congruent to KL, right? That's what the made an isosceles triangle. Okay, and then also ML is congruent to itself, right? That portion of the angle bisector right there is congruent to itself because it's the side of both triangles there. So we say the reflexive property. And then we also know the fact that this angle, I'm going to measure this, right? If we bisected this angle, then these halves are guaranteed to be, oops, I went the wrong way, congruent to each other. Right, so notice exact same thing, 58.76, 58.76, right? Cut it in half. So we're given the fact that these triangles here then have an angle pair that are congruent. So we're building the fact that we have JL congruent to KL. We have this angle that's getting bisected, therefore we have some congruent angles in both these triangles, and then they share this side ML, right, that segment of the angle bisector, they share that, so we also have a side right here that's congruent, right? So we've argued that we have these two sides that are congruent and an angle that's in between them, right, between the two sides. Right here, that angle that's made is congruent in both triangles. So that's what we consider a sides-angle-side relationship. So we can prove right now of what we know, that these two triangles have to be congruent to each other. And then, once we know that those two triangles are congruent to each other, right, just using symmetry, the fact that if you cut this triangle in half, this triangle would just fold right on top of this triangle. Therefore, this segment IK, or excuse me, JM, has to be congruent to this segment MK, right? JM has to be congruent to KM because they're corresponding parts of congruent triangles, so they're congruent. So what's known as our argument, we just write abbreviated as CPCTC. The fact that we have these two congruent triangles, therefore those sides then just have to be congruent to each other. So we know that they're congruent, and therefore we can prove M is the midpoint of that base, JK. So we have this picture, we have this proof, and it's proving that in all isosceles triangles, no matter what, right, no matter what your isosceles triangle looks like, that if you bisect this angle up here, then that bisector goes right through the midpoint of the base, right? It cuts it in half because we got these two congruent triangles getting made there with symmetry. So I hope that makes more sense of that proof, guys.